Good evening, dear students. This is Khadar, handling JEE and NEET classes of before you. Today, I came forward to explain one of the interesting topic that is redox reaction, one of the very important topic from the physical chemistry, that is our redox reactions. Okay, now let us start here. Redox reactions. Okay, now already we know first of all, okay, what is meant by redox reaction. Okay, now okay, redox reactions also we are seeing in everyday life. Okay, respiration process, photosynthesis process also we are seeing. Okay, next one, if you burn something, it is also comes under here. That is called as a combustion reactions, which is everything which is comes under here redox reactions. Okay, first of all, what is meant by here redox reaction? The term redox, which is okay, came from two different words. One is comes under red, second one here ox. Okay, red means here reduction, ox means oxidation. Very good. Okay, so that means what did you understand here? If you take any chemical reaction, okay, here both oxidation and as well as reduction takes place simultaneously in a particular reaction. Such type of reaction is known as here redox reaction. Okay, next one, what is the terminology which is okay, comes under this redox reactions terms? Okay, is very important. The first one is comes under here oxidation, second one here reduction. Just check, my dear students, here we know oxidation, that means we are okay adding, that is called as here addition of oxygen atoms, addition of oxygen atoms. Next one, the reverse here, the removal of hydrogen atoms. Next one, loss of electrons. Next, increase in oxidation number. Okay, this is called as here oxidation, addition of oxygen atoms, removal of hydrogen atoms, loss of electrons, and increase in oxidation number. Okay, that is known as here oxidation. Come to the reduction here, everything is reverse. Okay, here added oxygen atoms here, what you are going to add? Hydrogen atoms are you going to add, that means addition of hydrogen atoms. Next one, a removal of oxygen atoms. Next one, gain of electrons. Next one, here increase. Here what will happen, my dear students? Decrease in oxidation number. Decrease in oxidation number. That is called as here reduction. This is called as here oxidation. Both takes place simultaneously in the same reaction known as here redox reactions. Okay, this is the very important, my dear students. Okay, next one. If you take it here, okay sir, I with one example you can explain, sir. That means yes, we can take it one example. If you take it the general reaction, when carbon, it is a solid which is reactive with oxygen to form carbon dioxide, it is a gas and it is a gas. Okay, if you take the oxidation state of carbon is 0, later we can discuss here. Next one, here elementary form here is equal to 0, carbon here plus 4 and each oxygen minus 2, here carbon 2, okay, carbon here what happened from 0 to plus 4, here what happened from 0 to minus 2, 0 to plus 4, is it increasing or decreasing oxidation number, my dear students? Very good, very good. Okay, it is increase in oxidation number. Increase in oxidation number, it is called as here oxidation. Come here, okay, 0 to minus 2, from 0 to minus 2, decrease in oxidation number, decrease in oxidation number, it is called as here reduction. Just if you check it here, both oxidation and reduction takes place simultaneously in the same reaction, that is known as redox reaction. Okay, number of examples are there. Okay, next one, third terminology which is comes under here, okay, oxidizing and as well as reducing agent. Very important terms this is. Oxidizing agent, first of all I am going to explain. Okay, oxidizing agent, that means the substance which undergoes reduction or it gets itself getting oxidized is known as oxidizing agent. Okay, next one, come to the reducing agent. The substance which undergoes oxidation or itself getting reduced is known as reducing agent. Sir, I am having a bit confusion regarding okay, oxidizing and as well as reducing agent, sir. Can you explain with an example? Yes, just if you take it one example. Okay, when zinc which is react with HCl to form ZnCl2 plus H2. We take it as a solid, it is an aqueous medium, so aqueous it is gas. Okay, now zinc oxidation state here 0, but because it is doesn't combine with other elements, okay, 0, he reach hydrogen atom plus 1, here minus 1, here plus 2, here minus 1, 0. Okay, later we can do it. Okay, now from 0 to plus 2, what happened, my dear students? Increase zinc from 0 to minus plus 2, is it increasing or decreasing? Increasing oxidation number called as, we know oxidation, we already discussed here. Come, when with respect to hydrogen, from plus 1 to 0, plus 1 to 0, plus 1 to 0, what happened, my dear students? Decrease in oxidation number or not? Decrease in oxidation number. What I said, the substance which undergoes oxidation or itself getting reduced is known as here reducing agent. Oxidate, that means what you understand here? Oxidation means reducing agent. Reducing agent. Next one come to the here. Okay, decrease in oxidation number called as here reduction. Reduction means what is the agent? Oxidizing agent. Okay, plus 1 to 0. The substance which undergoes reduction or itself getting oxidized known as oxidizing agent. Have you all got the clarity about this one, my dear students? Yes. Okay, next one, come to how we have to assign oxidation number for particular elements or particular compound or molecule. Okay, we will be having some rules. Okay, we know that is the first rule. If you take it here, the oxidation number, that means what? The sum of the oxidation number of all the elements present in a molecule or compound is equal to 0. That means, present in a molecule or compound, you said no sir, is it a neutral or ionic? Very important point, my dear student. This is a neutral compound. Neutral compound. Okay, now is carbon dioxide is a neutral or ionic form? It is a neutral compound. Okay, the sum of the oxidation number of all the elements present in a molecule or compound is equal to 0. For example, we don't know oxidation number of carbon. Let me calculate here X plus how many oxygen atoms? 2. 2 into each oxygen atom here we discuss now is equal to 0. This is the way we have to study. Okay, this is the what, my dear, first rule. Sir, what about then ions are there, sir? Then ions, how can you calculate, sir, for ions? Okay, now for example, if you take it here, sulfate ion, same, nothing is there. Here there is no charge, that's why you put the 0. Here charge is there, it is equal to minus 2 or is equal to charge. That means I want to calculate sulfur, that means X plus each, how many oxygen atoms? 4. 4 into minus 2 is equal to charge minus 2. Then we can calculate here X. This is for neutral, this is for ions. Next one, if you want to know oxidation number for the elementary forms or the metals or uncombined state, that all the oxidation state which is equal to 0. Elementary forms, that means here H2, O2, Cl2, Br2, I2, O3, P4, S8, C60 and so on, etc. And metals, for example, iron is there, aluminum is there, that all, and metals is all oxidation state is equal to, my dear students, 0. Okay, that's why I wrote here carbon 0 oxidation state. I wrote here zinc, it is uncombined form, that is 0 oxidation state. Okay, now very important, hydrogen oxidation number. It's always you studied in hydrogen chapter. Hydrogen always plus 1 oxidation state, but except in hydrides. Hydride it exhibit minus 1 oxidation state. Best example you can take it here, sodium hydride or magnesium hydride. Here hydride. In organic chemistry also we are discussing hydride shift, 1, 2 hydride shift to get more stable carbocation. That means what here? Here hydride, that means here charge H minus. H minus, here plus 1 charge, here minus 1. Sir, is hydrogen exhibit 0 oxidation? Very good. That is what state, my dear student? H2 form. H2 is equal to 0. Next one, very important for oxygen atom. Sir, oxygen only exhibit minus 2 oxidation state. The oxidation state of oxygen in oxides always equal to minus 2. It is with respect to oxides. But what about with respect to peroxides, sir? Peroxides, that is minus 1 charge. Sorry, apart from anything is there, sir? Yes, that is called as here superoxide. superoxide here minus 1 by 2, minus half. It is superoxide, right? Okay, but this is peroxide bond we can discuss here. This is O2 minus. Superoxide here O2 minus. Next one, is oxygen gets zero oxidation state, sir? Yes, that is in elementary form which we mentioned in example 1. Okay, here zero oxidation state in general O2. This is the oxidation state of oxygen. Next one, sir, if any, okay, what about group of elements, sir? If first A group elements, what is the oxidation state? Already we know the +1. Second A group elements is there, it is +2. Okay, third A group element is there, that is +3. Fourth A group element +4. Sir, what about from 5th A, 6th A, 7th A and 8th A group elements? Just have a check it here. First, okay, 5th A, number of valence electrons minus 8. That is the formula. Number of valence electrons for 5th A group element 5. 5 minus 8 is equal to -3. Here 5 minus 6 minus 8 minus 2 minus 1 0. Here -5 is the minimum oxidation state and maximum is +5. Here -2 is the minimum, maximum is +6. -1 is the minimum, maximum +7. Here 0 oxidation state. That's why 8th A group elements are also known as okay, 0 group elements. We know noble gases, inert gases, aerogens, rare gases, everything we know. This is the oxidation state of okay, for particular elements. Okay, next one, let me calculate how to do it. For example, if you take it here, best example H2O. Okay, I want to calculate oxidation number of here oxygen that we say. Okay, that means sum of the oxidation state of all the elements. 2 into each hydrogen atom already we discussed +1 plus x is equal to 0. That implies x is equal to -2 oxidation state. Okay, next one, if you want to calculate here H2 SO4 H2 SO3. Okay, next one H3 PO4 KMnO4 and K2 Cr2O7. We know easily we can calculate sulfur here, here sulfur, here phosphorus, manganese, this one. Okay, now +2 each hydrogen I am directing directly, plus x plus okay 4 into -2 I am writing directly, -8 is equal to 0, x is equal to +6. Next one, if you do it here H2SO3 +2 plus x -6 is equal to 0, that implies x is equal to here +4. Okay, now if you want to calculate here H3PO4 ortho, okay, phosphoric acid, H3PO4 phosphorus I am doing +3 plus x. Okay, next one 4 2s are -8 is equal to 0, x is equal to +5. If you want to calculate here KMnO4 manganese potassium permanganate +1 plus x -8 is equal to 0, x is equal to +7. This is the way we have to calculate this one. Okay, potassium dichromate. If you want to write here, I am writing here K2Cr2O7. Okay, potassium calculate, sorry, chromium +2 plus 2x -14 is equal to 0, then x is equal to +6. Here each chromium atom which exhibit +6 oxidation state. Okay, dear students, please note down. Okay, let me continue of this one. Okay dear students, next one we know how to calculate here oxidation number, and few more examples are there here. Okay, it is completely mentioned in the our NCERT book. Okay, paradox oxidation states like that is there. If you want to calculate here oxidation state of carbon next one we know Br3O8 like this compound is there. Next one H2SO4 5 carbon here, this is called as carbon suboxide. Okay, here is oxide, here each carbon oxygen -2, here -2, here +2, here +2 becomes 0. Okay, here each the center of the carbon becomes here oxidation state 0. Here very important oxidation state in okay carbon. If you calculate directly it will come here +4/3 we know. Next one come to the here Br3O8 Br okay, now here each oxygen atom -2, -2, -2. Here what is the charge? +6. Okay, here -2, here -2, here -2. Charge is +6. Here oxidation state here -2, -2. Here +4. If you want to calculate the okay the average oxidation state here, how to calculate? +6, +4, +6 divided by 3, that is equal to here 12 plus 16/3. This is the answer. Very important. Okay, it is complete. Okay, it is mentioned in our NCERT book. Next one, if you take it here H2SO5 it is okay peroxy monosulfuric acid. Peroxy that means here one. Okay, peroxy bond will be is there. Peroxy bond, this is called as peroxy linkage. Yes, double bond O, peroxy bond here OH. Okay, H2S. Okay, O 1 2 3 4 5. Here each oxygen atom here -1, here each oxygen -2, here -2, here -2. If you calculate directly oxidation state of the sulfur, how much will come? Here 10 is there, here 2 is there. Direct it will, I am writing here +8 oxidation state. Is sulfur exhibit +8 oxidation state, my dear students? No. Very good. Why? Okay, now sulfur oxidation okay state is itself a +6 because it has 6 valence electrons. Okay, how the sulfur will exhibit +8 oxidation state? No, in entire periodic table osmium will exhibit osmium will exhibit +8 oxidation state. Okay, next one sulfur is a +6 is a maximum. Just I am calculating here 2 hydrogens here +2 plus X. Out of 5 oxygen atoms, okay, 3 of oxygen atoms are -2 charge. I am writing 3 into -2 plus to these 2 oxygen atoms is having a charge, okay, 2 into -1 plus 2 -2 both are cancelled here. X is equal to +6 oxidation state will be exhibit in okay, peroxy monosulfuric acid. This is the very important. Okay, my dear student, please note down. Remaining examples also we can discuss. Next one come to the here okay types of redox reactions. Very important. Okay, types of redox reaction we know. Okay, we will be having the 4 types of redox reaction is there. One is called as combination reaction. Next one decomposition. Next displacement reaction. Next disproportionation reaction. Very important reaction. This is disproportionation reaction. We know okay combination means both okay 2 atoms or elements which are molecules which is combined together in a reaction. For example, if you take example for the combination reaction, okay, same you can take it here H2 plus O2. If you take it here to form 2 H2O combination. Okay, now if you want to write here, is it comes under redox or not? Just check it. 0, here +1, here -2, 0 to +1 obviously increase in oxidation number, 0 to -2 obviously decrease in oxidation number. It is comes under okay combination redox reaction. Next one example 2 if you consider here decomposition reaction. Decomposition already you know one compound will be okay split up into more than one compound. For example, if you take it here potassium chlorate, if you apply heat, okay, thermal decomposition of potassium chlorate to form 2 KCl plus 3 moles of here oxygen. Here this is oxidation state here plus 1, chlorine oxidation state I am calculating here my 6 here plus 1, what is well plus 5, reach oxygen atom minus 2, here potassium is plus 1, chlorine is minus 1, here elementary form 0. Just if you check it, potassium doesn't change, yes obviously, chlorine plus 5 to minus 1, okay, plus 5 to minus 1 it is decrease in oxidation number called as red, okay. Next one here oxygen minus 2 to okay 0, minus 2 to 0, obviously increase in oxidation number called as oxidation. This also oxidation and as well as reduction takes place, that's why obviously it is called as redox reaction. Next one displacement reaction. Displacement already one example we got it here, Zn plus H2SO4 if you take it here, it forms ZnSO4 plus H2, here 0, here plus 2, here sulfur, okay, we calculated just now plus 6 oxidation state here also plus 6, here minus 2, each hydrogen atom here plus 1, here obviously 0, okay, 0 to plus 2, increase in oxidation number called as oxidation. Next one plus 1 to 0, decrease oxidation number called as reduction, it is comes under okay, displacement redox reaction, very important reaction, that is called as here disproportionation reaction. Disproportionation reaction. Okay, but sir, what is meant by disproportionation? Okay, now I am hearing it is a very new word to me. Okay, yes. Okay, but it is very important. Okay, keyword which is there in even P block and D and F block also we will be studying here. Disproportionation reaction. Okay, in a chemical reaction in which one element can be existing or can be act as a both oxidizing, okay, and as well as reduction in the same reaction. One element can be existing in oxidation or can be behaves as reduction. Such type of reaction called as disproportionation. Sir, give one example. Yes, Cl2 when chlorine which is react with sodium hydroxide, it is hot, okay, aqueous medium, hot and okay, aqueous medium. If you take it here, it will form NaCl plus NaOCl plus H2O. Okay, sodium chloride and sodium hypochlorite plus water. Okay, if you calculate oxidation number here 0, here minus 1, here what will the charge my dear? Plus 1. Okay, now here plus 1 doesn't change, minus 2 doesn't change, plus 1 doesn't change. Correct? Next one here chlorine, except chlorine all the elements okay has been oxidation number maintained the same. Okay, here 0 to minus 1, that is already we know that is called as a reduction. The same thing here 0 to plus 1, that is oxidation. Check the same element which okay exhibit or which behaves both oxidation and reduction, the same reaction is known as disproportionation reaction. Okay, if you check it one more different example, if you take it here, when phosphorus which is react with okay atmospheric conditions in alkali, it is forming here okay 3 moles of sodium hypophosphite plus forming here phosphine. It is a very important reaction which you studied in class 12 from 15th group elements. Okay, phosphorus here 0. Here what happened my dears? Here plus 1. Okay, next one. Here what is the oxidation rate here? Minus 3. Check 0 to plus 1 increase oxidation number. Here 0 to minus 2 decrease in oxidation number. The same element which exhibit both oxidation and reduction called as here okay disproportionation reaction. Very important type of reaction. Okay, next one equivalent mass calculation of oxidizing and reducing agent. Very important okay dear students, equivalent mass. Already we know equivalent mass how to calculate here. General I am writing molecular mass or molecular weight is divided by its valency. Molecular mass divided by valency. Already we know for acids we are calculating okay equivalent mass is equal to molecular mass for example okay molecular mass of divided by its basicity. Basicity means number of replaceable of H plus ions from one molecule of the substance. Okay, next one if you want to calculate for the bases, equivalent weight is equal to molecular mass of the particular base divided by its acidity. Acidity means the number of replaceable of okay, OH minus ions. Okay, next one if you want to calculate for the salts, how to calculate for salt? Equivalent mass okay molecular mass of the salt divided by okay next one total positive or negative charge on a particular cation or anion. Okay, next one very important our point, our subject here now. Okay, key point, oxidizing and as well as reducing agent. For okay, oxidizing or reducing agent, how to calculate? Same, molecular mass or molecular weight or the particular okay compound divided by okay change in oxidation number. Change in oxidation number. If you by using this one you can easily calculate. Okay, based on this we are going to solve some MCQ. Okay, dear students, please you can note down. And balancing okay, redox reaction, one small part is there and electrode process is there. Okay, now just you have to please note down. Okay, dear students, next concept is very important, balancing redox reaction in acidic, basic or neutral medium. Okay, let me take it here one example, small example, how to balance in acidic medium. How to balance redox reaction in acidic medium, very important, and can remaining also can easily understand here. Okay, acidic medium. Okay, now it may take it here, permanganate ion which is combined with which is ferrous ions in the presence of H plus. How it will be converted? It is converted into Fe3 plus and Mn2 plus. Then after completion of this one, I will give the one entire list. Based on that you can easily understand here. Okay, now MnO4 minus in acidic medium, it is converted into Mn2 plus, here Fe2 plus convert into Fe3 plus. Okay, just I am going to give the two or three steps we can easily calculate. Okay, step 1, what you have to do it here. Okay, balance the all the atoms except hydrogen and as well as oxygen. Except hydrogen and oxygen you have to balance entire. Okay, check it, manganese 1 balanced, iron 1 already got balanced, oxygen and hydrogen should not balance first. Okay, then after step 1, this is except condition. Step 2, what I have to do now, balance the number of electrons. Balance the number of electrons. I am calculating oxidation state of manganese here. MnO4 minus plus Fe2 plus gives rise to Fe3 plus Mn2 plus already we calculate here plus 1 oxide state, here plus 2, here plus 3, here plus 2. Just check it here, plus 7 2 plus 2, how many electrons got transferred my dear students? It is 5 electrons got transferred, 5. Okay, next one, plus 2 2 plus 3, how many electrons got transferred? Plus 2 2 plus 3, how many electrons? Only 1 electron got transferred. Just have a check to make the electrons balance. Here number 5 is here. Here what is the number? Here number 1. Okay, to make the balance, just I am multiplying by 5 here. If I multiply by 5, where it will be? I am multiplying here 5 Fe2 plus gives rise to 5 Fe3 plus Mn2 plus. Now electrons got balanced or not? Electrons got balanced. Okay, next one, come to the here step 3. Step 3, what you have to do? Balance first oxygen atoms. Balance oxygen atoms. Okay, oxygen atoms balance. For example, if you check it here, oxygen atoms here 4 left side and the right side no. This is RHS, this is LHS. Okay, here oxygen atoms here 4, here oxygen atoms here 0. Where if you want to calculate, if you want to balance the equation in acidic medium, where the deficient oxygen atoms is there, okay, for each and every deficient of oxygen we have to contribute 1 water molecule. That means how many water molecules we have to add to right side? Here 4 is there, here 0 is there. That means 4 oxygen atoms is deficient here. That's why I am going to add, in place of each oxygen atom I am adding 4 water molecules. Here 4 is there, here 0 is there. That's why I add, in place of each oxygen atom I am adding 4 water molecules. Whatever the sufficient part is there, okay, that side we have to add here H plus. That's why we have to add H plus. Here oxygen atoms now balanced or not? 4 oxygen atoms here, 4 oxygen atoms got balanced. Next one, come to the here hydrogen atoms, anything is there? No. Here hydrogen atoms, how many my dear students? 4 2s are 8. That means what? Since we are taking the reaction in acidic medium, acidic means obviously we know that is release of H plus ions. That's why I am writing here. Okay, here I am writing 8H plus. Okay, now sir, whether the reaction is got balanced or not, what is the any conclude step is there, sir? What is any evidence step is there, sir? Is there very important, that is 4th step. Okay, we have to check balance the charges. Balance the charges. If the charges of LHS becomes equal to RHS, the reaction, the redox reaction got balanced. Okay, check it, I am writing here left hand side here. Okay, oxidation, okay, what is the charge? -1. Here charge here, each fluid, okay, ferrous atom here ion plus 2, how many moles? 5 into plus 10, 5 into plus 2 plus 10. Next one here, each one is plus 1, 8 into plus 1 plus 8. Here 18, here -1. What is the charge my dear students here? Plus 17. Come to the RHS part. Okay, next one, here how much is there? Plus 3. How many moles? 5 moles. 5 into plus 3 plus 15 plus 2. Here water molecule in charge, it is neutral. That's why it is equal to plus 17. Okay, plus 17 minus 17, both are same or not? That's why equation got balanced. If you take any type of reaction, we can easily identify. Okay, now I am going to give here some. Okay, how it will be converted in potassium permanganate if you take it here in acidic medium. Okay, if you take it any oxidizing and reducing agent, how it will be converted. Okay, I am writing the list. This list is very important my dear student to calculate equivalent weight, and as well as it is also applicable for in the P block, D and F also, how to balance the redox reaction you can easily identify. Okay, I am giving the list in acidic medium. Check it here. Potassium permanganate in acidic medium gives Mn2 plus charge. Okay, next one, the same thing if you take it here in weak base. Okay, it gives here MnO2. Next one, if you take it here in the presence of strong base, it gives here MnO3. Okay, this is with respect to manganese, permanganate ion. Okay, if it react with some metals, if it react with some non-metals, if it react with some ions, how it will be behaves. Okay, now if you take it some metals, MnO4 minus plus Fe2 plus, if you take it here, it is common. Okay, in acidic medium tell you. Okay, Fe2 plus is converted into Fe3 plus This is called as this is called as ferrous, this is ferric. This is called as stannous, this is called as stannic. Okay, Sn2 plus. Next one, if you take it here, Pb plus 2 becomes Pb plus 4. Is a plumbous, is a plumbic. Okay, next one, nitrate ion, nitrite becomes nitrate. Okay, next one, sulfide becomes sulfur, sulfite becomes sulfate, phosphite becomes phosphate, oxalate becomes carbon dioxide. We have to take it 2 moles here, taken 2 moles, no problem. Okay, next one, I minus iodide ion, it is converted into I2. Okay, this is the some examples I gave how it will be converted in. Okay, this one. Okay, next one, if you take it here, potassium dichromate. Okay, what charge is there? Cr2O7 2 minus, that is called as a dichromate ion. This is dichromate ion in acidic medium. In acidic medium it is converted into Cr3 plus. Since it contains 2 chromium atom, I am writing 2 Cr3 plus. Okay, in case of if you take it here basic medium, it is converted CrO4 2 minus. This is dichromate, this is chromate. Okay, now if you take it here weakly base or neutral medium. Neutral medium, if you take it here, which one we are going to take? Okay, I minus, it is converted into very important, this is IO3 minus. Okay, this is the very important thing which you are studying. While you are balancing the equation, you must remember, okay, these are all the charges. Based on that, you can easily calculate any type of okay, balancing reaction. Okay, next one, small, okay, this is the very important. Next one, okay, just if you take it here, redox reactions and electrode process. Okay, electrode process already you studied. Okay, this one it will again you are going to study in electrochemistry. Okay, in electrochemistry already we know. Okay, next one, electrochemistry, if you take it here, okay, in terms of electrode processes, how we have to use. Okay, just I am writing here, already we know electrochemical cell. Electrochemical cell, the device in which the chemical energy which is converted into electrical energy is known as electrochemical cell. Okay, I am taking here 2 okay, beakers. In that one beaker I am taking here zinc sulfate solution. In other beaker I am taking here copper sulfate solution. Okay, now I am immersed with here zinc metal. Okay, next one I am here immersion with this is copper metal, and both are connected with the help of okay, through wires in there, which is connected with 1 voltmeter. This is okay. Next one, here voltmeter whether working or not, here flow of electrons, and very important going to introduce, that is called as here I am going to introduce one of the YouTube okay, which is inverted into the two beakers. Okay, now here zinc sulfate, that means here what type of ions it will be taking here, Zn2 plus ions. Okay, and here Cu2 plus ions, it will be dissociation takes place. Sir, what is this one, sir? Is there any significance is there, sir? Here that's okay. This is salt bridge which is containing U2 which is inverted in a 2 different beakers. Sir, this is what is the importance of the salt bridge, that means here, and what type of electrodes you are taking, that is called as okay, inert electrodes. Inert electrodes such as KCl, KNO3. Okay, next one, which is agar jelly. Okay, you are completely studying. Okay, in electrochemistry also you might have been studied. Okay, sir, what is the main purpose we have to use this salt bridge? Okay, this name is, sorry, okay, I forgot to introduce you, that is called as here salt bridge. Okay, now this salt bridge, what is the main significance? To be maintained electrical neutrality. Because of that only, okay, we have to use this salt bridge, electrical, to be maintained electrical neutrality, because this is the purpose we have to okay, use here salt bridge. And whatever the ions are there, okay, these ions will not be mixed with the copper sulfate and as well as zinc sulfate solution. Here zinc rod which is act as here okay, electrodes, and as well as here copper acts as a electrode. This is I am considering here anode, and this is I am considered here cathode. Generally the okay, reaction will be taking place is like this here, electrode reaction, means Zn plus Cu2 plus gives rise to, this is solid and this is aqueous medium, gives rise to Zn2 plus Cu. This is aqueous medium and this is solid. If you want to calculate here total, okay, one small tool is there, already we know everyone, okay, LOAN. This is called as a left side oxidation takes place, that is called as anode and its charge is negative. Left side oxidation, anode, it's called as a negative sign. Next one more word is that is called as RRCP. R means here right side, what will takes place? Reduction takes place. What is the here? Electrode, cathode, and what is the sign significance here? Positive. RRCP, LOAN. Left side oxidation, okay, anode negative. Right side reduction. Next one, cathode, this is a positive. That means here left side oxidation takes place in this diagram here. Right side, okay, okay, right side here, okay, what is the cathode? That is reduction takes place here. This is the net reaction. If you can calculate here, E naught cell is equal to here E naught of cathode minus E naught of anode. This is the standard electrode potential for this one. Okay, which compound or which metals having the, okay, most, okay, negative E naught values, which shows, okay, maximum reducing character, maximum reducing agent or maximum reducing character. Generally, obviously we know generally metals which shows maximum reducing character. Next one, if you take it here, most positive E naught standard electrode potential value, which indicates here, okay, maximum oxidation nature, that is called as maximum oxidizing nature. Here generally we know metals best reducing agent, whereas non-metals best oxidizing agents. Okay, dear students, please, okay, be noted. Okay, next slide we are going to discuss some MCQs based on whatever so far we discussed. Okay, this one. Thank you, dears.